You're going to see all these are interconnected with the parallelograms that we've already done. So getting started, first of all, a rectangle is a parallelogram. That's the first thing you need to know. And since it is a parallelogram, it has all of the properties of a parallelogram. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, diagonals bisect each other, and the diagonals, and the same side interior angles are going to be supplementary. Those 5 properties that we had all for parallelogram, it's going to share all 5 of those same properties. But it is also going to have these. So it's going to be a parallelogram with 4 right angles. It is going to be a parallelogram with 4 right angles. That is what makes it a rectangle. A parallelogram with 4 right angles is going to make it a rectangle. Okay? Now, that is going to be very connected to the next shape, which is going to be the same idea, but then which one's next, guys? Huh? Squares? I thought rhombus was next. Look and see. I think rhombus is next. So, a rectangle is going to be related to a rhombus, and then those two are going to be related to a square. So let's show you what I mean. A rhombus, guys, still has all of the same properties. They're listed here. All 5 of those properties that we talked about for a parallelogram. So it is a parallelogram. These are all parallelograms, just so we know, guys. With, and guys, what makes a rhombus a rhombus? Look on the picture. 4 congruent sides. It is a parallelogram with 4 congruent sides. That's exactly correct. Now, guys, what other shape do they call a rhombus? It is a diamond. Just so you know, the EOC may say diamond. When they say diamond, they mean a rhombus, just so we're clear on that. If you know anything about diamonds, it's called a marquee cut on a diamond. That's what the shape this is. Okay, so it's just going to be a parallelogram, so all the same 5 properties, but now you've got 4 congruent sides. And there's actually 2 other properties we'll talk about in a minute that make it a rhombus, but that's the main difference. Now, what we're going to do for the next one, which is a square, I think we said was next, that's going to be the combination of everything for a rectangle and everything for a rhombus put together. Okay, the special things about each one of those go on a square, both of those. It's the most special type of parallelogram. So it is still going to be a parallelogram. That word takes forever to write. A parallelogram. So it still has all 5 properties that we were talking about before, but now it has the properties of a rectangle and the properties of a rhombus. So it is going to be a parallelogram with 4 congruent sides. That's the first part. There you go. 4 congruent sides and 4 right angles. 4 congruent sides and 4 right angles. Take a minute, write it down. Make sure you got it written down before we move on to concepts. Okay. So 4 congruent sides, 4 right angles puts us at the most special kind of parallelogram, which is going to be a square. And in a square, we start getting to the idea that because it has 4 right angles, it also makes it a rectangle. Guys, because it has 4 congruent sides, it is also considered to be a rhombus. Now, is every rhombus going to be a square? No. Is every rectangle going to be a square? No. Can it be? Yes, but no, it's not always. Is every square going to be a rectangle? Yes. Is every square going to be a rhombus? Is every square going to be a parallelogram? Yes. Good. So we got the connections. Let's talk about why it's connected in properties. So when we look at this, guys, I didn't make you write them out again because we already learned these. These are the 5 properties that we already have. What we have is 2 new ones when it comes to a rectangle. Notice the properties that we have. So there's 7 of them for a rectangle, but we already know these 5. The only thing we're adding is these 2 new ones that go for just a rectangle. So when you talk about it, we already did the one with the right angles. So we have 4 right angles. That part you already know. That was in the definition. There's one other thing. about the diagonals. I drew it on the picture, but the diagonals right here are also going to be what to each other? Huh? Not parallel. They are still bisecting. Now they are still bisecting. Absolutely still bisecting. So that's in our, that was number 5. But that makes them congruent too. Diagonals are congruent. You can use the symbol or the word. I don't care, guys. Symbol or the word. Diagonals are congruent. And that idea of parallel is not parallel, but the idea of something like that's going to show up in a second. So that's a good one to come into in a second. That's why I didn't want to say no, it's not, like it's wrong. It is wrong in this case, but we're going to use something similar to that in a minute. So definitely headed in the right direction. Okay, guys, when I ask you about the properties of a rectangle, you're going to use the 5 that we already have for a parallelogram, and these are the only 2 things we're adding. The diagonals are congruent, and you get 4 right angles. Okay, that's what makes a rectangle a rectangle. Now, let's talk about what makes a, what's next? Rhombus a rhombus, I think? Let's do that one. So, as you can see, the first 5 properties are the exact same first 5 properties that we already have. My line didn't go through there. The first same 5 properties that we had for a parallelogram. We're adding 3 new ones because it is a rhombus. So we already talked about in a diamond, in a rhombus, you have 4 what? 4 congruent sides. Okay, 4 congruent sides. Now, guys, they are not the easiest thing to draw. They are not. But I need you to draw one so that we can make some connections. So take a second to draw a rhombus. I know some of y'all it's going to take a little longer than others, so I'm going to give you a minute. Draw a rhombus. Usually I draw all your pictures for you, so you don't have to do this very often. Try to draw a rhombus. Okay. Because this is a rhombus, we know it has 4 congruent sides. Mark that on there first. Now the other 2 involve the diagonals, so I would like you to draw the diagonals. It takes a second because I know it's not, y'all don't draw a lot. I don't make you draw a bunch of pictures in this class because it's pre-printed notes. It makes it a little easier. Okay, guys. Now you can tell, are those diagonals the same length? No, that doesn't happen in a diamond or in a rhombus. But those diagonals do 2 things that are very important. Look at how they intersect in the middle. Okay? They're going to form right angles all in here in the middle. That means those lines intersect, and that's called what kind of lines? Instead of parallel lines, it's going to be what? Perpendicular. So the diagonals are perpendicular. Okay, remember the symbol for perpendicular is that upside down capital T. I'll put that there just because I'll probably use that symbol later. I want to remind you what that is. But perpendicular lines really mean that you get what? What do you get there in the middle that really matters? 4 right angles. I want to make sure you understand that that's the important part, because we're going to be finding angles in pictures. That's the main thing that you have to do on your homework tonight, is find angles in pictures. So knowing that these are right angles every time is going to be important. 90, 90, 90, and 90. Now there's something else that the diagonals do, so let's just write this down, then we'll talk about it in the picture. The diagonals bisect opposite angles. Diagonals bisect opposite angles. I'll give you a second to write that down, then I'm going to talk about it in the picture. Okay, then we'll talk about it in the picture. All right. Now in a rhombus, it's very special because you basically get 4 congruent triangles here because it's bisecting the opposite angles here and here. So let's just say that this whole angle is 120. If this whole thing is 120, when it's cut in half, this side would be 60 and this side would be 60. Then by alternate interior angles, if this is 60, this angle down here would also have to be 60, and this one down here would also have to be 60. Alright, hey Swim. Just grab that sheet. Then, by the idea, guys, this is like from chapter 2. Thank you. This is like from chapter 2, guys. If you have 90 and 60, that gives you 150, and 180 minus 150 would leave you 30 for the other angle. But guys, if this one is 30, then this one would also be 30. And by alternate interiors, this one would also be, and this one would also be 30. Do you see how it's 4 of the exact same triangle just shoved together with all their right angles in the center? It's always like that in a rhombus. Makes it really easy to find missing angles. Okay, anybody have any questions about that picture? Because we're going to be doing, again, a lot of what you do tonight is that kind of example. Now we have more examples to do on that, but that's a lot of what you use the properties for, is to do that. Okay, here we go. The last one of these then is going to be, what's left? Square? Okay, oh, question? Yeah, please, thank you.
Can you tell me where it says above perpendicular?
4 right angles, that you get 4 right angles right there in the middle. I just wanted you to understand what perpendicular meant. Thank you for asking and not just going on, and thank you for telling me. Okay, I appreciate it. Anybody else? Okay, here we go. Last one of these before we talk about all of them together is going to be the properties of a square. Now guys, this should not be complicated because you actually already have all the information for these. None of this is new. So we already talked about the fact that we already did the 5 for a parallelogram. For a square, you're just going to add to that the 2 that we learned for rectangle and the 3 that we learned for rhombus. So the 2 that we learned for rectangle were that there are, what was it, 4 right angles was first? 4 right angles. And then the diagonals are congruent. 4 right angles and the diagonals are congruent. That's what makes a rectangle a rectangle. Well, that stuff is also true in a square. I'm sorry. Then we add in the 3 more that we learned for rhombus. Now the 3 more that we learned for rhombus are 4 congruent sides. What is the next one? Diagonal, I think next was diagonals are perpendicular. Is that the next one? Diagonals. Bless you, I think. I can't tell if people are coughing or sneezing. I apologize if I miss one, guys. Bless you. Oh. Diagonals are perpendicular. And then the diagonals, this is the one most people miss, guys, so be careful. Diagonals bisect opposite angles. The diagonals bisect opposite angles. Diagonals bisect opposite angles. Okay, do you understand in a square there's nothing new? We've got the 5 that we had for a parallelogram. We have these right here that are going to be for a rectangle. And then we have the 3 that we had for a rhombus. And all together, they make up the ones that are going to be for a square. Okay? Anybody have any questions? Mia, pay attention to notes. Come on. Everybody's good? Okay, here we go. Let's show you how they fit category-wise. Guys, look at me. Venn diagrams. We've done these lots and lots and lots of times in your life. Let's hope you see what we're talking about. These overlap each other, guys. They share things in common. Because of that, we're going to talk about them. The first thing is the whole big box is about quadrilaterals. What do we know? What's the only qualification you have to be quadrilateral? You have to have what? 4 sides. Because the words actually mean, quad means 4, lateral means sides. 4 sides. Quadrilateral, 4 sides. Okay, so the biggest one, the one with the 5 properties, the biggest category in quadrilaterals is called what? Parallelograms. Parallelograms is the biggest category. But within parallelograms, we then have these 3 other things. Okay, there's the one that gives us the 2 properties. What one has two extra properties? Rectangles. And, no, that's spelled wrong, isn't it? Isn't it G-L-E-S? That looked really weird. Like that, right?
Yeah.
I knew it was wrong, it just looked strange. Okay, rectangles. What's the one that adds three properties? Rhombus. And then, what's the one where it adds all 10 properties together? It's the most special. Squares. Now, okay. Now, if I made these notes, this would be different. Because, guys, if it's going to be squares in the middle, don't you think you'd make the one in the middle look like a square? It bothers me, but it's squares. Now, there are two other types of quadrilaterals. They're going to be the next two sets of notes we do. Does anybody know what they're called that don't fit in these categories? Ooh, nobody? Okay, trapezoids is one of them. Because they only have one pair of parallel sides, so they fit out in kind of like the strange group off by themselves. There's another one. What? A kite. Nice. You're the first person that's got that today. Nicely done. Kites. Kites are very weird, guys. Kites have all these strange properties, like the sides that are congruent are next to each other. Only one of the diagonals is bisected, but not the other. One of the sets of opposite angles is bisected, but not the other. Kites do very weird things, because a kite is one size on the top and then different sized on the bottom. It's a very strange shape. It's kind of like that weird uncle that is kind of strange when it comes to family reunions. You have one, because I do. So here we go, guys. Anybody have any questions just about the categories, like how they fit together? Okay, let me ask you this. Is a trapezoid a quadrilateral? Yes. Is a trapezoid a parallelogram? No. Is a square a quadrilateral? Is a square a kite? Is a kite a parallelogram? No. So, guys, it's overlapping or it's not. Does it include it or not? Let me know if you have any questions about that. That's what this is for. So if you're having any issues, they do a lot of true-false with this, let me know. Okay, so now to the real problems for today. This is what you're going to be doing on your homework. One, you're going to have to identify. So, tell me what shape example number 1 is. It is a rhombus. Now, they already told you, if you need water, feel free to get some, sweetie. They already told you it's a parallelogram, but they want to know, is it a rhombus, rectangle, or square beyond that, the specific name. So we said this one is a rhombus. What about, now example 2 goes to the right, guys. Example 2 right here would be a what? Square, good. Nobody's having any issues on these. That's good. This is a square. Okay. What about example 3 down here in this corner? This is a rectangle. Good. Because you've got opposite sides congruent. You've got the 4 right angles. Good. Okay, now on this next one, they don't give you a lot of information, but you can get there. Because if the lines are parallel, and this is a 90-degree angle by same side, this is going to be 90. And then because these are congruent, it's cutting off equal parts, the opposite angles are going to be congruent to it, so this is going to be 90 and this is going to be 90. And if the lines are parallel and they're congruent to each other, they're going to cut off equal parts, so this side's going to be congruent to this side. It's like that big picture that you were asking me about at the top of the page on the assignment earlier. So what shape does this make it? A rectangle. Very nicely done. Okay. Anybody have any questions? Yep.
How is it not a square?
Because it does not have all 4 sides congruent to each other. The only thing we know is that these 2 are the same as each other and these 2 are the same as each other, not that all 4 are the same. Right? The way we figured out that these 2 were the same was because they're cut off on parallel lines, so they're cutting off equal parts. But we have no idea if this amount right here, which could be 10, would be the same as this one, which might be 12. We have no way to know that whether they're the same or not. They could be, but we don't have any way to prove that. Good question. Anybody else? Okay, here we go. Last piece of this then is going to be, well, there's 2 it's involving finding missing angles, finding missing variables for the sides. So let's show you the angles first. So when you're looking at this picture, this is the rhombus. This is probably the number 1 thing that's going to be on the homework. This is the main type of problem you're going to see, is taking a picture and finding missing parts. The angles, I don't have any fear of you finding these angles. First, guys, we're going to start here in the middle because it's angle number 1 and it's easy. Anytime you have a rhombus, those angles in the middle are always going to be for what? Right angles. So they're all 90 degrees. There you go. 90, 90, 90, and 90. So the measure of angle 1 is 90. Okay? For the next one, if this angle right here, this one, look up here, is 41, this one right here, then this angle on this side would also have to be 41. By alternate interior, this would also have to be 41, which would also make this one 41. So angle 4 is 41. Questions? Guys, it's because it's always going to repeat itself 4 times inside there. Every one of those is going to repeat 4 times because you got 4 congruent triangles. Okay, last one of these is going to be to find the angles. The last of the angles to find, excuse me, is going to be 41 plus 90 because we're going to use the idea that every triangle adds up to 180. So that's going to be 131, and 180 minus that 131 is going to leave us what, guys? 49. Now, guys, that means this angle is going to be 49, which means this angle is also going to be 49, which means by alternate interior, this is also going to be 49, and this angle is also going to be 49. So 3 and 2 are both going to be 49. Just on the angles, do you see that it's the same triangle 4 times over? It repeats it's literally like have you ever seen where they do that thing where they just kind of flip it over, flip it over, flip it over, and it just keeps making the same shape again? That's this. It's just the same thing repeated 4 different times. Okay? The sides are a little different, guys. I'm going to change colors so you can see it. We're going to start by looking at each piece of this. First of all, if this side is 13, because it's a rhombus, all 4 sides are the same, so all 4 sides are going to be 13. The next thing you're going to see that this piece is 5. Guys, if this piece is 5 on this side, then this piece has got to be 5 on this side. Now, we don't have anything for the other way, so we're going to have to manipulate and find that in a second, but let's take a look at one of the answers. See FH right here? FH is asking for this whole thing. So how long would that whole thing be? 10. Just add the 5 and the 5, you get a total of 10. That one doesn't require much work. That one's pretty straightforward. The next one requires some work, and it's a matter of whether your teacher taught it, and I know we've got COVID, so we're dealing with that. I'm going to teach it like you've never seen it. Guys, if I take one of these triangles, and I'm going to draw it out here to the side, just separate, completely separate. It's going to be a right triangle, where I know this side is 13, I know this side is 5, and I don't know this side, so I'm going to put an X on it. That's this piece right here, from J to K. This is X right here. That's what I'm trying to find, is KJ right there. Guys, anytime that you have a right triangle, you can use this formula. K squared plus B squared equals C squared to find the missing side. What is that called? Nice, Pythagorean theorem. Second person to get that today. Pythagorean theorem. Pythagorean theorem says that anytime you have a right triangle, you can square the 2 legs, and it will be equal to the hypotenuse squared. The hypotenuse, or the C, is always going to be the one across from the right angle. We've actually already used this year, but I'm just teaching it like you've never seen it. That's going to be A squared, which, guys, it doesn't matter which one we call A. I'll call it my 5 squared. So 5 squared plus, we don't know this one, so we're going to call it X squared is equal to our hypotenuse squared, which our hypotenuse has to be the one across the right angle, has to be the longest side, so it's going to be 13 squared. Okay, guys, what's 5 squared? 5 times 5 is 25 plus X squared equals, what's 13 squared? 169. We're going to solve this equation, minus 25 minus 25. It makes it X squared equals, you do the math. What's 169 minus the 25? 144. Okay, ooh, look, guys, what's the opposite of addition? Subtraction. What's the opposite of multiplication? What's the opposite of squaring something? Square root, the root of it, taking the square root. So we're going to put the radical sign over both of them, take the square root, and x is going to equal, what's the square root of 144? 12. There you go. That's our missing side, 12. Alright, guys, Pythagorean theorem is something they expected you to bring into here with you when you came from middle school, or from before this class. We use it in Algebra 1 here at Leon, but it just depends on what you saw, and because it depends on when you took it and what you dealt with COVID, so I'm teaching it like you've never seen it. But it is something you're going to have to be able to use on this test and a lot going forward. We're going to do a whole section on more of it, getting involved with it, but that you got to know how to deal with that. Okay, the last thing on our notes today. Let's go ahead and get to this real quick. Okay, because I want to give y'all some time to get some missing stuff if you need it. So our last thing today is going to be about a rectangle. Guys, this is a rectangle. A, B, C, D. You always draw a picture if they don't give you one. They're talking about find the value of x and the length of the diagonals. There are the diagonals. Guys, AC would be a diagonal, BD would be a diagonal. What do you know about the diagonals inside of a rectangle? They're what? Equal in measure or congruent, however you want to say it. Their measurements are going to be equal to each other. So guys, these are not complicated problems. They're just set equal to each other. 3x plus 7 is going to have to equal 5x minus 11. Which x would y'all move? 3x. That'd make it 7 equals 5x minus 3x is 2x minus 11. Right, add 11, add 11. 18 equals 2x. Divide by 2, and 9 equals x. Take that x that's right here, because guys, it doesn't ask just for x, it asks you to find the length of each diagonal, so you got to plug it back in. 3 times 9 plus 7 makes it 27 plus 7, which means each diagonal would be 34. Now, guys, I picked the second one for 2 reasons. The second one's here for 2 reasons for the arithmetic. Guys, x equals 4x minus 12. What am I moving first? The 4x. Because I need the 12 to be by itself, so I'm going to minus 4x minus 4x. That's going to make it negative 3x, because 1 minus 4 is negative 3, equals negative 12. And I'm going to divide both sides by negative 3. And x is going to equal 4. Perfect. Now, this is the second reason I did it. It's really strange because, guys, if x equals 4, then the diagonal is also going to be 4 because it's just x. So it's the same answer both times. The diagonal and x are the same thing. So I wanted you to see that does happen. Okay, guys, that's your notes for today. Let's go ahead and take a minute and put that in your folder where it goes, and then I'm